we're going to talk about what is the definition of plane stress. So if we have our stress element here at any point, and we have, there's in certain cases, the stress in the z-axis as well as the shear stress along the z-axis would be equal to 0. So in that case, all of these terms that I'm highlighting within our stress matrix would all be equal to 0. All right. So our 3 by 3 stress matrix will become a 2 by 2 stress matrix, which you can see on the left hand side. All right. So what this looks like is that we have in 3D, what this would look like is we have our normal stress, sigma y, our normal stress, sigma x, as well as our shear stresses, tau xy, and our shear stresses, our shear stress is tau xy on all of the faces here. All right. So what this ends up looking like is oftentimes instead of drawing out the full stress element, you draw something that looks like just a square. All right. Well, we'll just draw out our shear stress, tau xy, and then our normal stresses, sigma x and sigma y. Okay. So whenever you see this 2D drawing, it is represented a 3D stress element, but since all the z components of our stresses in both the shear and normal stresses are equal to 0, we can simplify our drawing and just draw a 2D box. So this is a very important case that we'll come back to often, where we'll say that a material is in plane stress. All that means, again, is that the components of the stress along one direction, both the normal and the shear stresses are equal to 0. And we can simplify our matrix down to a 2 by 2.